This is the video for Chapter 13.3, Math 2020. We're talking about another transformation. This time it is a dilation. The transformations we've talked about so far, the translations, the rotations, and the reflections, they are all isometries. And you remember that we talked about the fact that in an isometry, the image and the pre-image are congruent figures. It doesn't change the shape or the size. It just changes the position. In a dilation, the size changes. So however big the original is and how big the image is, that's the scale factor. So in this picture, we have the little picture inside the projector and the big one on the screen. They are a scale factor of 20. In this figure, we have two triangles. You can see them, the blue one and the black one. In the black triangle, the triangle ABC, you see that the two legs are 3 each. Well, in the legs in the big one are 6 each. Right, so we've doubled everything. So the scale factor for this will be 2. You also notice that there is a line, a ray actually, that is drawn from O through A, and then it also hits A prime. So they are collinear. So the center of dilation, the image, and the pre-image are all collinear. So the definition, the precise definition is saying that it is a mapping on a plane to a plane with center O. If the scale factor is R, then it's a transformation that assigns each point A to an A prime such that they're on O, A, and A prime are collinear. And the distance from O to A prime is twice the distance from, or whatever R is, right? So if R is 5, then it would be 5 times the distance from OA. So R is that scale factor, then that's what you multiply the size by. So we can go lower. We can go with a fraction, and it just turns out the other way, that the A prime would be between the O and the A. So let's just look at what we have to do here. As we have a center, if we have a center and we draw the line from O through each one of those, and then we mark the line at 1/2, that is going to give us our new figure. So we have the line OB and 2/3, sorry, not 1/2, 2/3, because it's the scale factor, sorry. It's the scale factor, 2/3. We draw the point 2/3 of the way, that's our B prime. And we do that for each one of them, then that gives us a figure. And that figure, A prime, B prime, C prime, D prime, that's similar to ABCD. So same shape, but different size. So if you have your worksheet, look at your worksheet there with 13.3. We're going to do these 4 problems. We'll look at the first one together, and then I'll have you just turn off or pause the video and do the others. So it's kind of hard for me to draw this. I'll try to make it a So I'm looking at the ray that starts at O and goes through each of those points. So not as accurate as you're going to be able to do it with your straight edge. Stylus isn't that precise. All right, so I'm going to erase this so that you can actually see. It won't erase if I have it big. Okay, so looking at it, stop it, jeez, okay. From O to A is 1 square. So I need to go from O to A prime, and it's got to be 2 squares in that same direction, right? So it's going to hit it right there. That will be my A prime. O to B, so you can see that it's the diagonal of that little rectangle up 3 over 1, right? And so we would just do that again, and it's going to be right there. And then to go from O to C, I'm going up 1 over 1, 2, 3, 4, 5. It's that little rectangle, the diagonal of that rectangle. So I go again, 1, 2, 3, 4, 5. That's going to be right here, right? So this little triangle here, that is my similar triangle. And every side is twice as long as the other. So my the little black triangle, the original one, is 1, 2, 3, 4, 5 along a side. And so this one should be 10. Right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Sure enough. Right? And so when we use this method of getting a similar triangle, as you'll notice in the next one, we have the same triangle but a different center, but I still get the same similar triangle, the same size, but it changes where it is. Okay, so pause the video, do these next 3 problems, and then turn it back on and we'll see how you did. Okay. Sorry. Okay, so in this one, we've just moved it a little bit. The O is moved over just one place. But now you see that this distance is a diagonal, so I'm going to go along that diagonal twice as far because it's still scale factor of 2, and there's my A prime. So to get from A or O to B, I'm going up 3 over 2, so I'm going to go up 3 over 2 farther to go twice as far, so that is my B prime. And then to get from O to C, I went up 1 over 6, so I'll go up 1 over 6 again to get my C prime. All right, so those two the 2 orange triangles in the first 2 problems are actually congruent, right? They both have a scale factor of 2 and they're coming from the same triangle, but they are in a different place in the plane, right? They were shifted a little bit different. So in this one, this trapezoid, I hope you found that, I hope you noticed that the center is inside, but this time we're going out 3, not 2, but 3, scale factor of 3. So I'm still going to count out best I can since this is a grid. I can still look, this is just on the diagonal, so I'm going to go out 1, 2, 3 on that diagonal. Over to P from O, it's going to be up 1 over 4. So I'll go up 1 over 4 and then up 1 over 4 again. So that would be my new point. Down here is over 1 down 2. 1, there'd be 2, which I could have known it was going to end up on here. And this is also a horizontal line, so I just have to figure out where it stops. And from O to A is going to be down 2 over 3. So I go down 2 over 3 again, down 2 over 3, and that's my other point. So if you've done it right, the angles stay the same, right? This had some right angles here and here, so the new one has some right angles. Okay, so this one is a rectangle, the new one will be a rectangle. This time we have a scale factor of 1/3. So here we went on the diagonals down 3, so we're just going to go here. And this one is going to be up 2 over 1 and 2 over 1. So the 1/3 of those. And from O down here, we're going to down 1. 1, 2, 3, 4, 5, 6, 7, 8, 9. So down 1 over 3. Down 1 over 3. All right, so there's going to be the image of that one. And I can tell from there, I know it's going to be a rectangle. Okay, so here's the key to remember. The image of a line segment is still a line segment, but it is r times as long. So whatever the scale factor is, it will be that many times as long as the original. But the image of an angle is still an angle, and it's the same angle, and it doesn't change side. So we mentioned when we talked about the other isometries that if two figures were congruent, there would be some kind of a isometry that mapped one onto the other. And the same thing goes with similar figures, that there's some combination of a isometry, some isometries, and a size dilation that will get one onto the other. So for example, these two figures are similar. One is just larger than the other, right? Now I could do this all in one dilation. I could find the center. Oops. Okay. Yeah. Okay. I could, using a straight edge, of course, to make it accurate, right? I could make that go there. I could do the tails. Oops, I didn't quite make the tail. I could do the little toes here. But you see that they're all going to connect in one place, and that would be my center, right? And then I would be looking at how far it is here compared to here. So it looks like, I don't know, maybe it's a third, or maybe it's more complicated than that. But as far as the distance, now it doesn't have to be just a dilation. I could I could translate this little dog over to here and then make it big. I could match up a point. I could make that my center of the dilation. I could reflect it a couple of times. It is going the same direction, but you know, we can use any of those rotations, or any of those transformations, any of those isometries, and a size dilation, and that would give us a similar figure. So we can construct a dilation just with a compass and straight edge, just like we have before. And I'm going to show you a construction, which of course is not going to be up. So there we go. Let me just get in here and show you the dilation of a triangle. So there's the center, and now it's making the triangle that I'm going to do the dilation on, ABC. So see if you can figure out what the scale factor is. So there are the lines, and you're just using your straight edge to do that. So you notice that the compass measured from O to A and then is marking it off 2 more times. Then it measured from O to B and then is marking it off. And then from O to C and then it's marking it off. So those 3 new points are the points of our new triangle. All right, so did you notice what the scale factor is? That scale factor, how much farther did we go down the line? Well, we went 3 times farther. So the scale factor was 3 in this case. And I didn't need to know the numbers and multiply by 3. I just went that far using the compass. So I want you to do this on this triangle. So you can ignore the Q because that is from a different activity that I did not include in here. But P is going to be our center, and you're going to dilate ABC. And the way they are setting this up, the way they're asking you to make a segment where PA is the same as A prime. So that means you're going, A prime is twice as far. So this will be with a scale factor of 2. So I'm not going to try to draw it because I just showed you one with scale factor was 3. So I know you can do this. But you do the lines, you mark off the places. Okay, so one of the applications we use with the dilation transformation is in a perspective drawing. So we can make things appear to be 3-dimensional, and a perspective drawing is used often in art, as you have that vanishing point, or that knowing that perspective where it's going into the distance, right? That's kind of what our center of dilation would be. So if you were to look here, we have this letter C, and we started off with this letter C right here, and we draw all these lines that go out to O, and then you're going to choose some place. So I don't know, this one is looking, maybe it's at 1/3, or maybe it's at 2/5. I don't know, maybe it's at 3/5. No, that would be bigger than half. So let's say it's at 1/3 or something. Then this is a similar figure that we've done. Okay, so we could erase all these lines out here, but we'll keep these lines that connect. So we either don't draw or we make them dotted if they would be on the back side of our figure, because that would be not shown, right? Not seen. So that's kind of what you would do with the letter C. Here's another example with the letter F. You can see all those lines to all those little corners. We erase all those lines. I've made them dotted here, but you can just erase those lines and then have this three-dimensional figure. You see that we do have this F in the background here. That's one of our F's. And then we have a similar one that's smaller in the front here, right? So connecting all those lines kind of makes it look three-dimensional. So your next task, this is not just part of this assignment. You can spend the next week on it. You're going to make a perspective drawing. I want you to make it nice. Don't just throw something together in 2 minutes. Take some time at it. Make it a good job. Erase the lines that you drew in order to create it and make it just look like it's these three-dimensional figures, right? So I want 3 things on the paper. It can be 3 letters, it can be shapes, it can be like a triangle, it can be a rectangle, a trapezoid, it can be a star, whatever you'd like. It can be your initials if you want. But make it go to the one point of dilation so that it's three-dimensional going off into that vanishing point. So there'll be a assignment on Canvas. You can turn it in a picture there, but I also would like you to bring your picture to our Zoom meeting next week and show the rest of the class some of the things that you've done. So I want to see people's pictures, your perspective drawing pictures. I'll be looking forward to seeing what you come up with. But that's it for 13.3, and we'll talk about it in class next time if you have any questions, and then we'll be getting ready for the test. Bye.